Of course, you can imagine like engineering work to be all cold, rigorous, and without emotion, but actually it's quite the contrary, because especially when you're doing research, there is always the excitement about the discovery or the confusion about results that they don't make sense. Also the frustration if something is not working, because at the end here we are developing new thing, we are creating new thing. When this thing works, that's really a nice feeling, it's really rewarding. I'm Maicol. I did my bachelor's degree in mechanical engineering in Bologna, and since 4 years I'm a research engineer at Inspire and a PhD student at ETH. We are producing mechanical parts made of metals, typically steel, and we are producing them by adding material little by little at the end, allows us to create even complex shape and parts. I would say that the most challenging part in additive manufacturing is that when you create a component, everything you did before influences the current state of the process. And the temperature evolution during the process is one of the main drivers for your final part quality. At the moment in the industry is missing a tool that helps production engineer to plan the production. The focus of my research is thermomechanical modeling. I'm trying to make a model that is able to simulate and predict how the temperature will change during the process. You really need to have tools that allows you to predict what's going to happen during the process. If you're able to understand how the temperature field will change during the process, then you will most likely succeed in producing a good quality part. It's really easy to get blinded by your own ideas, and when you work in a team, when you have the possibility to discuss with colleagues about the topic, that's actually where innovation takes place.